Today I wanted to do a video to describe in a little bit more detail how we graph equations in standard form. Standard form of a linear equation is given in the form ax plus by equals c, where a, b, and c are all whole numbers. X and y in this case are going to be on the left. I say on the left of wherever our equal sign is here, and only a constant on the right. Now a constant, remember, that is a number by itself, meaning there's no variables. So for standard form of an equation, both of your variables are on the left side, only a whole number is by itself on the right. So we're going to do some examples. My first example here, I have 3x plus 2y equals 6. Now how we're going to graph this, probably the easiest way to graph standard form, if you are able to do it, is through the cover-up method. Now the cover-up method cover-up method. This is going to be the easiest way if you are able to do it. Are we always able to do it? No, but we're going to try. With the cover-up method, we are looking for the intercepts. Now, in finding the intercepts, we have to recognize what an intercept actually is. First, I'm going to look for, in my case, the x-intercept. Now, the x-intercept is going to be here on the x-axis. Now, recognize if we're on the x-axis, that means we didn't go up and we didn't go down. So if our point is on here, our y-coordinate is going to equal 0. That is how we're going to do the cover-up method. I'm going to first show why it works, and then I'll do it in our little quick, fast method there. Fast way to do it. So finding the x-intercept first on the x-axis, knowing y is 0. I'm going to take my equation, and I'm going to make y is 0. 3x plus 2 times 0 equals 6. Knowing y is 0 because I'm on this line. Well, anything times 0 is 0. That's going to go away. That leaves us with 3x equals 6. If 3x equals 6, I can divide by 3 on both sides to get x equals 2. If x equals 2, I'm going to go on my x-axis, plot a point right there at 2. Next, I want my y-intercept. That's going to be on my y-axis, which is this guy right here. Same idea, if I did not go to the right and I did not go to the left, then x is 0. And I'm going to solve it the same way. I'm going to put a 0 right in for my x. So now 3 times 0 plus 2y equals 6. Anything times 0 is nothing. That means 2y equals 6. I can solve here by dividing by 2. And y equals positive 3. 1, 2, 3. Plot that point. Ooh. Do these videos in live time. I almost sneezed. You guys do not need to listen to that. Oof. That's what happens when you do videos without cuts. All right. Connect my two intercepts right there. There's your line. Now, why do we call this the cover-up method? If you look at what we did, whenever I put in a 0, that term is going to go away. So it's like this term doesn't exist. So if I take my finger and actually cover up the variable I don't want, in this case, finding my x-intercept, if I cover the y, I'm left with a 3x and a 6. That was the equation that I left with. Same, if I want to find my y and the x is not there, I cover that up, I'm left with a positive 2y equals 6. That's what I ended up solving. So that's where the name the cover-up method comes from. Let's do another example where we're going to do the cover-up method, but I won't write it with the zeros in there. We're just going to plot. I'm going to know that this 2y is going to go away when I want to find my x. So negative 5x equals the number on the other side, which is negative 10. I can divide both sides by negative 5. Cross that off there. X equals positive 2. On my x-axis right here, I'm going to plot a 2 right there. Now for my y, the x is going to be gone, so I'm going to keep this side. 2y equals negative 10. Divide both sides by that 2. Y equals negative 5. Down 1, 2, 3, 4, 5 on my y-axis. and I connect my dots, pretending I can draw a straight line. Okay, now I'm not fully done with my standard form because it is not always going to be this easy. I want to show you guys an example where maybe the cover-up method is not the best method to use. Let's say I try to do the same thing with this equation here. If I take my x, in this case it is a 3x, equals a negative 8 on this side, and I divide both sides by 3, then x equals negative 8 divided by 3, that's negative 2 2/3. If we try to graph that, that's going to look really weird. I'll still show you, but it's not going to work. If I go over here, 4y equals negative 8, divide by 4, y equals negative 2. That one looks better. But let's say I tried to graph that right now, really fast. Draw my lines. Boop, doop, doop. Dun, 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 dun. All right. My y is easy, negative 2 down here. But let's say I tried to do x at negative 2 2/3. That's going to be like here-ish, right? This is not an exact science. This could be 2/3. This could be 3/4. This is not going to be perfect. So I would not draw that line that way. Instead, if you don't get a whole number, you're going to convert this. So I'm going to put that little star. No whole number. My sneeze is coming back. Oof. If there's no whole number, we are going to convert to slope-intercept form. Now I have a separate video on slope-intercept form, also in my graphing playlist, so anybody can go back and find that. But let's do another quick example of that for you here. We have 3x plus 4y equals negative 8. If I want to convert this to slope-intercept form, I have 2 steps. My first step is going to be to move my x to the other side. In this case, it is a positive 3x, so I subtract. Minus 3x, minus 3x. That guy goes away. 4y equals negative 8 minus 3x. My second step is divide by the number with y. In that case, it's 4. Divide everything by 4. Y equals negative 2 minus 3 over 4x. Now, if I make my graph here, make that a little bit bigger here because I got to get in the negatives. Plot some lines. Get ready to plot my line. Okay. We know from my previous video, we begin at our B, which is our y-intercept. That is a number with no x. In that case, it is negative 2. Again, if you forgot that, you can look at my other video. We are going to begin at our B, which is negative 2 on the y-axis. Right there. Now, our slope is the number with the x. In this case, a negative 3 over 4. Negative 3 over 4. Negative means we move down. And then we go to the right. Down 1, 2, 3. Right 1, 2, 3, 4. Whoop, I went up a little bit there. Not doing this on graph paper. Probably should invest in that sometime soon. And then, assuming I draw a straight line, I'd still be about my 2 2/3. Again, assuming that I can draw a straight line. On a regular graph paper, doing this online, this is a much more accurate line than you would get up here. So if you are doing the cover-up method and you get a fraction or an improper fraction, a mixed number, if it's not a whole number, convert to slope-intercept form. For more detail on how to convert to slope-intercept form, please look at my other video. Until then, follow along for more math explanations.